everyone. For today's lesson, we are going to review quadrilaterals and parallelograms. For today's lesson, please make sure that you have some colors with you. Make sure you have something to write with. And you might also want to have your interactive notebook that has all of the properties that we've talked about so far, like parallelograms, rectangles, rhombuses, and squares. So what we're going to do to start off is I would like you guys to please go ahead and pause the video, and I would like you to please go ahead and mark up this quadrilateral chart to the very best of your ability. Write down what you remember. Don't look at your quadrilateral chart that we've created in class. I want to see what you know and what you don't know. And then once you have an answer, please go ahead and restart the video, and we will see how well you did. All right, let's go ahead and check out what you know, what you remember. So in this quadrilateral chart, we're really just focusing on the center. At the very top, we have a quadrilateral. And a quadrilateral has two properties. Number one, it has four sides. Number two, all angles add to 360 degrees. So that is a quadrilateral. Quadrilaterals have three different sections. The first section is trapezoids. Trapezoids simply have one pair of parallel sides. That's it. There's nothing to talk about when it comes to their sides, their angles. It's still a four-sided figure. All of the angles do add to 360, but it only has one pair of parallel sides. Below it is an isosceles trapezoid. It has one pair of opposite sides that are parallel, one pair of opposite sides that are congruent, and as we get further along, it has base angles that are congruent to each other. The diagonals are also congruent, and you'll learn about that later, but the diagonals do not bisect each other. Over here, this is a kite, and a kite has no parallel sides, but it does have consecutive sides that are congruent. It does have diagonals that do not bisect each other, but instead form right angles. And the diagonals only bisect one pair of angles. That is it. It does not bisect any other angles, so just one pair. So this is a kite, and these are trapezoids. These are not going to be on this first quiz that you guys are going to be taking. Instead, so I just wanted to give you an overview of those shapes. So we haven't talked about them yet, but I wanted to give you guys a heads up as to what those are. Instead, we've primarily focused on the center. These are parallelograms, and a parallelogram has the following properties. First of all, a parallelogram has opposite sides that are parallel. So whereas the other shapes that I just talked about only has one pair of parallel sides or no parallel sides, a parallelogram has two pairs of parallel sides. It also has two pairs of opposite sides that are congruent. It has opposite angles that are congruent. It has consecutive interior angles that are supplementary. It has diagonals that bisect each other but are not congruent. And that is a parallelogram. Parallelograms have special shapes that are also parallelograms but have additional properties. The first one is a rectangle. A rectangle has opposite sides that are parallel. It does have opposite sides that are congruent. But the angles, although it is true that opposite angles are congruent, they are also right angles. And as a result, 90 plus 90 is 180, so it is true that the consecutive angles are also supplementary. The diagonals still bisect each other, but what makes a rectangle special is that they are also congruent. The diagonals are congruent. Next, we have a rhombus. And a rhombus, it is true that it's a parallelogram, so opposite sides are parallel. And it is true that opposite sides are congruent, but more specifically, all sides are congruent. Parallelograms have opposite angles that are congruent, and that is true with a rhombus. Opposite angles are congruent, but they're not necessarily right angles, like a rectangle. They're going to be other angle measures. It is still true that these angles are going to be supplementary. The consecutive interior angles are supplementary. So it still has those properties up here of a parallelogram. And the diagonals do bisect each other, but the diagonals have special properties. They're not congruent, like a rectangle's diagonals are congruent. A rhombus's diagonals are not congruent. But they do intersect to form a right angle. So they're perpendicular bisectors. And an additional property is that the angles, the diagonals bisect the opposite angles. So that is true as well. The diagonals bisect the opposite angles. So these two angles will be congruent, these two angles would be congruent, these two angles would be congruent, and these two angles would be congruent. Finally, we have a square. And a square has all of the properties of a rectangle, rhombus, and a parallelogram, in that the opposite sides are parallel. The opposite sides are congruent, but not more specifically, all sides are congruent, just like a rhombus. The opposite angles are congruent, but more specifically, all angles are congruent because they're all 90-degree angles from a rectangle. The consecutive angles are going to be supplementary. 90 plus 90 is equal to 180, and they get that from parallelograms. The diagonals do bisect each other. They bisect each other, but more specifically, they're congruent, just like a rectangle. And they intersect to form right angles, just like a rhombus. But the diagonals bisect the opposite angles as well, just like a rhombus. So if this is 90 degrees, half of 90 is 45. So we have a bunch of 45-degree angles going all the way around. Every single one of these is 45 degrees. And those are all of the properties that we know of parallelograms, rectangles, rhombuses, and squares. We know that as we look up the chart, the answer is always true. Always, like a square is always a parallelogram. It is always a rectangle. It is always a rhombus. Going down the chart is sometimes. A parallelogram is sometimes a square. It is sometimes a rectangle and sometimes a rhombus. A rectangle is sometimes a rhombus only if that rhombus is a square. Vice versa is true too. A rhombus is sometimes a square, but a parallelogram is never a kite. Neither is a rectangle ever a trapezoid. So if there's no connection, then we say that it is never. So remembering all of those for our statements is going to be really, really important. Let's go ahead and use this chart to answer our next question. So in example number 2, what we want to do is we want to figure out what is the most specific name for this quadrilateral right here. What we have marked up is that we have not just that the diagonals bisect each other, but the diagonals are congruent. Parallelograms do not have diagonals that are congruent, neither do rhombuses. A square does, but I don't have more information to tell me if the diagonals are bisecting or if the opposite sides are all congruent. So therefore, D has to be my most specific name based on the information that's given. Number 3 says, tell whether the statement is true or false. The diagonals of a rectangle are perpendicular. This is false. The diagonals are not perpendicular. They are perpendicular in a rhombus and a square, but not a rectangle. Diagonals of a rhombus are congruent. This is also false. The diagonals of a rhombus are not congruent, but they are perpendicular. So maybe if these two terms had flip-flopped in our sentences, it would be true. Letter C says, if a quadrilateral is a rhombus, then it is a square. This is also false. That would indicate that if a quadrilateral is a rhombus, it is possible to draw a rhombus without right angles. So therefore, the answer is false. If a quadrilateral is a rectangle, then it is a parallelogram. This is true. And that's because all rectangles have the properties of parallelograms. This is a parallel symbol, ograms. If a quadrilateral is a parallelogram, then it is a trapezoid. This is false. There is no connection. Remember, a parallelogram has 2 pairs of parallel sides, but a trapezoid only has 1 pair of parallel sides. Let's go ahead and look at example number 4. What I would like you guys to please do is please go ahead and try example number 4 on your own. In this problem, we want to name all of the quadrilaterals that each statement describes: parallelogram, rectangle, rhombus, and square. So name all of the quadrilaterals that the statement describes. So for example, both pairs of opposite sides are parallel. So you're going to write down that that is a property of a parallelogram, rectangle, rhombus, and a square. Both pairs of opposite sides are parallel. It works for all of them. So please go ahead and complete B, C, D, and E. Pause the video and complete those, and G, F and G, excuse me. A, B, C, D, E, F, G. And then I want you to restart the video so that you can see how well you did. All right, let's go ahead and check your answers. So for letter B, what we have is we have both pairs of opposite angles are congruent. So both pairs of opposite angles are congruent. So that is true for parallelograms. Opposite angles are congruent. That is true for rectangles, rhombuses, and squares. The diagonals are perpendicular. That means they intersect to form right angles. That is only true for a rhombus and a square. The diagonals are congruent. That is only true for a rectangle and a square. The diagonals bisect the opposite angles. That is only true for a rhombus and a square. All angles are right angles. That is only true for a rectangle and a square. And all pairs of consecutive angles are supplementary. That is true for all of the shapes: parallelograms, rectangles, rhombuses, and squares. And that is the end of today's lesson. If you have any questions over anything that this lesson was talking about, please feel free to email me. Otherwise, I hope you have a wonderful day.